I am Jesenko Mehmedbasic. I am originally from Bosnia. I've been in Denmark since '95, and I'm a senior software developer at Partisia. And the agenda for today, we're gonna talk about our tooling, how it looks like, what it does. Then we're gonna try to interact with a token contract by writing some bytes in a hex editor, which is very technical, but I'll keep it on the slide. And then we're gonna talk about an ABI and what an ABI does. And then we're gonna look at what the recommended ways of interacting with our blockchain is. Let's take a look at the tooling here. We have on the left side a smart contract source file, usually a lib.rs. It contains your serialized state, your public actions, your zero knowledge actions. You feed this into our cargo command, cargo Partisia contract. You type build and you get out two files, a WASM file, which is your bytecode, and an ABI file. If you have anything that's zero knowledge related, we feed that into a zero knowledge compiler, which Jon talked about. And then you get another WASM file which has a different extension just to distinguish them. So the WASM or ZKWA files, they're your code, and the ABI file, it's your interface for the contract. So let's take a look at it, at some source code here. We have the token contract in our examples. These two are parts of that's like something the blockchain gives you. It's not part of the RPC. You don't supply this as a caller, so we just ignore those. So we have like an action called transfer. We have something like denoting an action up here, and then an address and a value. The short name and the arguments encoded in binary, that's what we call the RPC, remote procedure call, if for anyone who doesn't know that. The short name, it's basically just to save space. It lets the blockchain know which function to call, and if you have less than 255 functions, you can just send one byte instead of sending the entire 7-8 long string that's called transfer. The arguments are all encoded in binary, and if you, the slides will be up, if you want to look at it, there's like a link, and then you can see what's actually inside a payload for this transaction we're going to make. So I made a contract called Bada Croissant contract token, and I accidentally typed BTC, and I kept it because it was funny. And this is a contract on our testnet. It's a token contract. This is what it comprises of, and it's deployed on the testnet. So let's try to transfer some butter croissants. We want to send 32 of those to the address 00121212. Etc. So the short name was the first part. It's easy, it's just a 1. And then the address is just, it's hex encoded already, so we just send it like that. And then the value of 32 is 20 in hex. So, but how do we encode the 20 in hex? It has, it's 64 bits, so you have 8 bytes to encode. We have to choose some form of encoding. So there's little, big endian, leb128. Let's try what our processor uses. It uses a little endian. And then we can see, the first part, it becomes the 1. This becomes the address, and then you have the value. So 20 is at the beginning, followed by 7 double zeros. And there's a reference mode, you can see it. And then the chain expects big endian. So what you just sent, instead of sending 20, you sent this number and lost all your money. So we want to, when we interact with a blockchain, we want to use something that helps us code these bytes or encode these bytes correctly. And that's what our ABI can help us with. It's short for Application Binary Interface. The most famous example is probably Win32. The Windows ABI, you can still run programs written 25 years ago on your modern system, and that's because they've kept that part stable. The smart contract ABI, it's like the programmer's interface to interacting with your contract. It tells the consumer of the contract, like which features it uses. Does it have enum structs, what their fields are, which actions it has, like we saw before, what their arguments are, and how do you interpret the state of the contract. So if you look at this slide again, this is the fun part we're talking about today. It's the ABI, it comes out there. So they're generated as a part of the compile step, and they're in binary format. So let's take a look at a snippet. So we have an ABI snippet, and this is a little technical, so we'll just skip over it quickly. The first part here, this is the ABI for the action transfer. The first part, it's 8 characters long. It comprises of some ASCII, and it's transfer. This is the short name. It has 2 arguments. The first one is 2. The address type is encoded as a 0D. Then you have value, which is 5 long, and it's a 04. And to help us with this, we've made some tooling, of course. So we've made something called an ABI client. We have 2 versions. We have a Java one and a TypeScript one. So let's look at if we input this ABI we just generated into the TypeScript one. We get a RPC builder. We write the the action name transfer. We write the address, and then we write the wrongly typed value there. There should be 32 there, but it's 20. Assume that this number is 32. And then you get the RPC we're expecting. You get the short name, you get the address, and the 20 as a big endian. So what do we use it for in Partisia? Well, we generate all the UI controls. If you go back a couple of slides, you saw the Bara Croissant overview. That's automatically generated from the ABI. And all the action, or you send an action, is also everything is generated from the ABI definition. Then we have feature flags on it. If you're using zero knowledge or not, our blockchain knows it. We use it for versioning, so we can actually take a contract compiled today and run it even though our chain has moved on. So we can run backwards compatible contracts. And it means we can recompile a contract that's old, and it gets new features afterwards because our ABI is versioned. And it makes us possible to do the extensive amount of tests that Jens talked about. We basically, every integration test we run, we input the ABI as a part of the contract, and then we can use it to encode the interactions. Without the ABI, it would have been like handwriting bytes all the way. And in the very near future, we are working on, very near, like today, we're working on code generation based on the ABI. So we can generate some type-safe code. Instead of going, like a couple of slides ago, instead of writing new transfer, add this, we generate some code with this yet to be released piece of Java code. This will probably change when it's released. And then you get this very, very fine piece of Java. And if you can't read Java, it's basically the same as TypeScript if you squint a little and maybe drink a beer. And then you get a blockchain address. This is a little verbose. You need a blockchain address from string. But then instead of writing transfer and stuff, you can just write token contract dot transfer to 32. And if we print it, it of course prints the same because I'm awesome. Or it would have printed. The other one would have printed something else, but this one would print the right thing. It's much more compact than actually writing the bytes, and it's readable by basically everyone on your team. And it's much safer to work with. So right here, if someone mistypes transfer in the Rust file, now in the other slide you had to write it yourself. It looks it up in the ABI and you get an error. Here you get a compile time error, so your project won't build if you make a typo. If you attempt to supply something here that's not a 64-bit integer, you'll get an error. And now for the future of our tooling, with this addition of the ABI code generation, we'll be having a JSON format instead of the binary one, because we know that everyone on our team loves binary and loves hex editors, we're not sure that everyone else in the world does. We'll have a Java RPC builder like you saw with the TypeScript. It will be released probably early 23. followed closely by the TypeScript one. And then if anyone has ideas for tooling or what's missing from the tooling, we hope that after today you can get some new ideas and let's have a chat about it. So in conclusion, one wrongly placed byte can cause a lot of harm. And you should use all the provided tools you get to get as much help as you want, because they're constantly evolving and adding new features and new safety stuff. And we're evolving it towards making the default case a very safe way to interact with contracts without the possibilities of breaking your bank account by accidentally sending 20 in the wrong order. Thank you.